Welcome back to the channel. In today's video, we're going to be doing episode 7 of the Maserati Biturbo build series. In this video, Martin is going to be starting on the header system and starting to build the exhaust for this car. So let's get right to it. Martin has started work on the header systems for the Maserati Biturbo. This is Steven's turbo. It is a Garrett G25 660. Now, one of the cool things about this turbo is it's straight V-band on the exhaust side of the turbo, which allows us to go into a V-band here. Now, what we're going to do for this car is what's called a tri-Y system. So you have 4 runners for the headers, and they're going to have a separate Y each like this that goes into one, and then have a third Y that runs into the turbo here. Now, what Martin has tried to do here is make this as smooth as possible on the inside and clean it up so that there's lots of good airflow and nothing gets caught up. Even just the smallest little fibers will get your exhaust much hotter. If it's nice and smooth on the inside, the air won't turbulate and won't have any heating issues. And one of the great parts of having a tri-Y system is that instead of having a 4-to-1 collector at the turbo, which collects a lot of heat because all of that air gets choked up into one small collector, you have a much more flowy header that has nice good airflow through both of these Ys and into the third. So one of the most important parts to making a tri-Y system work properly is to have equal length runners meeting up to both the first 2 Ys and to the third here. This allows for both the best power and the best sound. So Martin is actually being able to use Teflon wire to make sure that the runners are all the same equal length. And So one of the most important parts to building a header is planning out material usage. You know, there's a lot of different materials that people will use for the headers. For example, the header in the Starlet is 321 stainless. But because this car is a street car and a turbo car, it's going to go through a lot of heat cycles because turbo cars run extremely hot. So we know that it's going to get hot and then cool back down, and it's going to be doing that a lot as a street car. So what we're actually using in this car is 304 stainless, but a specific type called Schedule 40. Now the bonus to using Schedule 40 is it's extremely thick, which gives you not only, thick material for strength, but also a lot of welding area so that when you do weld these together, your weld can be extremely strong and survive hundreds, if not thousands, of heat cycles. So that's what we're going to be using in this car for pretty much the entire header system. It's also a little bit cheaper than using mandrel bent tubes, being able to get the cast, tubing like this, and then just weld it together the way we need. If you guys see a lot of like OEM turbo cars, almost all of those will use some kind of cast stainless header. That's exactly what the Jaguar XJ220 that we have at the shop right now is using, because it's so good at being able to go through lots and lots of heat cycles without cracking or breaking. One of the biggest bonuses to using this 304 cast stainless is it's a lot cheaper. For example, the headers for the Starlet are out of 321 stainless, like I said, and the material alone to build those headers for a 4-cylinder was over $2,000. We'll be able to build Steven's header for much cheaper than that and still have a reliable, good working turbo header. So Martin is currently doing one of the most important parts to building the exhaust system for a turbo car. It looks a little bit weird right now, but this is just Martin's, easy way to visualize things and kind of get an idea. Turbo placement for a, turbo car is probably the most important thing when you're trying to do, your header and exhaust design, because where it sits relative to the headers is going to change how you have to make your headers both for equal length and just for, placement. And then it also determines where your actual 3-inch exhaust comes out and has to fit down the back past the steering shaft. And it also correlates to where it comes in from the intercooler. So everything is just tied in together, and where you place it is extremely important for both, you know, what it is now and for everything else related to the car in the future. So after some planning and some thought, Martin has decided that this is exactly the turbo placement he's going to go for. He put a little bar here and tack welded it so that it would hold, and now he can start to kind of plan out the header lengths and how he wants to run the headers to the turbo. So one of the coolest things that we actually have made for this car is this stainless steel exhaust flange here. So Steve didn't really like the one that came with this car and knew that for turbo, oh my gosh.
What? Bro, what are you talking about, man?
And knew that for turbo application that it would be best to have a much thicker, beefier stainless steel flange. So when he made Martin's car, he made an extra couple for the other projects that we had lined up. And Martin has used it as a little tack weld on to be able to continue to work on the exhaust, and is now going to plan out his runners to the 2 Ys that come up to this. Now that Martin got his turbo placement down, he has this bar welded on to hold the Y that goes onto the turbo in the correct placement. He took the flange off and is now going to weld on the first of the 4 runners, which will allow him to then cut off this bar and move on to the rest of the headers. Of course, it's really important for him to check the length. The length was done mathematically by Martin and Steve together based on prior knowledge of engines and how to make a tri-Y system work both for power and for sound. So Martin is going to set up the length on that one perfectly and then be able to match the length on the rest of the runners once the bar is out of the way. Now with this specific car, as well as with Martin's car, the way we're setting up the tri-Y is that the outside 2 runners will meet in one Y, and the inner 2 runners will meet in the other Y that then go into the 3rd Y and into the turbo. The reason that we're going to do this is for both power characteristics and for sound. Now with most inline-4 engines, the way that the engine works timing-wise is that the outside 2 cylinders will fire, 1 and 4 will fire 360 degrees apart. And so you want to have these going into the same Y so that you have an even fire pulse in that. It gives you, number one, the best power characteristics, a really nice flat, broad torque curve, as well as it gives you a great response for throttle and for other things as well as sound. And then the inner 2 again also fire 360 degrees apart in the firing order, which allows them to again have that even fire pulse. Martin was able to finish tack welding this one runner here and was able to take off the metal bar on the 2nd runner, which means he'll now be able to put it in the car and test the fit, make sure this runner will fit properly and not hit anything or get in the way of something. And then from there, he'll be able to fully finish welding it and move on to the next 3.
We're also making sure the turbo placement is what we want.
So also being able to have the one runner done and tacked on will allow Martin to actually bolt the V-band onto the turbo and have the turbo placed where we want it and be able to test that it clears the hood and kind of visualize where everything's going to run and be able to make decisions.
Got big turbos now.
So this is kind of where the turbo is sitting for now. It's currently a little bit higher than Martin maybe would have liked personally, but it still might work. Martin kind of has to decide for himself now if he wants to change the header to lower the turbo down into the car a little bit, or if he just wants to leave it and continue on with the rest of the headers. So Martin's made the decision that he wants to lower the turbo a little bit. He's gonna have to modify the header that he's already done to do this. He wants the turbo to kind of sit flush with the top of this, like right here. So the top of the turbo sits there. It's currently about maybe 1/4 of an inch high. You know, when you weld things, the metal kind of warps in its own way, and this is something you can't really control, but you just have to plan for and be able to fix if necessary. This is the beauty of being able to tack weld something before you fully weld it, so that it's much easier to take apart and change something in the future. So Martin made the modifications to lower the placement of the turbo, like we said, and then decided that he was happy with it and fully welded the first runner. And now it's time for him to begin planning the runner that's going to run into the same Y, like we said. So that's going to be runner number 4. It's really important that Martin makes all of them equal lengths, so that's what he's going to be doing now, and is planning out how he wants to run it to make space for the rest of the exhaust as well as the other 2, while also keeping it that same length. So this is kind of Martin's initial plan for this runner. He's tack welded the back pieces, and then as you can see, he's run it really straight compared to the other tube. Again, this is because it's got to be equal length, so it's all just about getting to the same point and being the same length as the other runner. So Martin was able to finish the remaining 2 headers, and it's kind of been sitting for a couple days, but one of the last things that Martin did was to smooth out the inside of these ports here. I'll have to brighten that up so you guys can see it. But basically it's really important that you get these ports to be really smooth so that there's nice good airflow and none of the carbon builds up right there and causes your exhaust to get hot or to clog or have any other kind of issues. Now that the headers are done, Martin's going to be able to move on to making the wastegate. We're using a Tial 38mm wastegate. Martin's going to have to run the actual wastegate pipe off of here as well as mount it to the side of the Y here, you see. You can mount it right there to the side. And once we have that, we'll be able to install everything and test our fit. Martin is just kind of snugging the header on so that he can plan out a path for the wastegate to go. It's one of these things where you kind of have to plan not only for where it fits now, but for where everything else is going to go, like the intake for the turbo and everything else. So you have to plan around that and kind of make sure that you put the wastegate in a place where it's out of the way of everything else. So Martin's initial plan on this wastegate is to have it mount here to the back of the Y, and then run the actual wastegate tube from there down to the right of that steering shaft, because the actual 3-inch exhaust that's going to come off the back of the turbo here is going to run down to the left side of that steering shaft. And so that right side should be open, and we should be able to run the wastegate pipe right down that. We will have to build a nice heat shield for the brake master right here to make sure that doesn't get hot with the wastegate pipe and the headers right next to it. But that'll be something that we'll have to build down the road. Martin finished welding the pipe right here. Now that that's on, Martin can bolt everything onto the header and bolt the wastegate on, and then plan out the actual pipe for the header and the rest of the exhaust. So that's going to be it for this video. Thank you guys so much for watching. In the next one, we're going to be buying the intercooler for this car and working on the custom intercooler end tanks, and then Martin might be starting the rest of the exhaust for this car as well. We'll see you guys then.